So hey guys, welcome back. This is Abhishek again, and I'm back after a long time. I'm really sorry for that. I was suffering from some sort of virus. So I have been working on natural language processing for a long time, and I have uploaded so many videos on natural language processing. And this is kind of a very different video. And in this video, I will talk about the state of the art technology, state of the art architecture for our NLP task. So we have pre-trained model for every task, and you can even create a model. You can create a natural language processing NLP model in just 5 minutes by using pre-trained NLP models, pre-trained NLP models. So in this notebook, in this video, we are going to do emotion detection, emotion classification, and that is our multi-class classification. And we are going to use a BERT model, and that is a very modern architecture for our NLP task. And this is state of the art model. Like you will never get more accuracy than this. You can use every model, you can use NLTK, you can use whatever you want, but you won't get more accuracy than these models, right? So if you are learning NLP, you should definitely know about this. So in this model, we are going to do emotion detection. Again, I said multi-class classification, and I'm going to do this on TensorFlow, right? Okay. So before begin that, I want to explain you something, right? Okay. So don't worry if you don't know about BERT model and all these things. Just stick with me. I will explain every line of code. So just don't worry. And there is a website that is called huggingface.co.models. Just head over that, and in the left side you will see there is many tasks like fill mask, question answering, summarization, text summarization, that is text classification, translation, and so on, right? And you will see here some models, and those are pre-trained. And okay, suppose I want to do a text classification, right? So I will click on that, and you will see that here I will get so many pre-trained model. And you will see that this model have the maximum downloads. So I will click on that. So let me tell you again, this is Distilbert model, and that is really good model. This is lightweight model, and this is same as BERT model, but this is lightweight than BERT, and somehow achieve the similar accuracy. Okay. And this is light model because it has less parameters, right? So you will see that, and this is some learning rate, and here you will see there is a web service called, and this model is pre-trained. It means you can directly predict whatever you want. Okay. So suppose I want to predict, suppose I would say that I hate you very much. Okay. If I compute that, it will say negative, means sentiment is negative, right? So this model has been trained to predict sentiment, and this is again a binary classification. But what would happen, how would we do a multi-class classification or some sort of, suppose if we want to create a news fake news classifier, so if we want to use these pre-trained model, then how would we do that? So the problem is, how would we do that? And for that, again, if you remember your computer vision, there were also pre-trained models. So that was quite used, right? That was all those VGG60, InterSNet, and ExceptNet. Again, they were already pre-trained, and we had used to extract features. So the same thing we are going to do here. So what would we do here? Suppose if we want to do multi-class classification, so we will fine tune these models. Like we will train them again on our custom data set. We will train them again on our custom data set. So this is all about the BERT model. So BERT model is made, okay, wherever BERT model is, let me show you. If you don't know BERT model, you can read about blogs everywhere on internet, but let me tell you a little bit about that BERT model is launched by Google, and this model is used for various tasks. We can use for text classification, we can use for text generation, and this model is made to predict the masked word, right? So suppose Paris is the masked of France, like okay, this word has been masked means hidden, so how would we predict that? So if we click on compute, so you will see that it is showing the capital of France. Okay, so if we want to use the translation, you can also use that. So here we have a pre-trained model. So suppose I want to convert English to Russian, so whatever language you want, so that is English to Russian, just click on that, and this is a word in English. If I compute in that, so this is in Russian, so this is in Russian, right? So and this is pre-trained. So I was talking about that you can create NLP task, NLP models in just 5 minutes. So you have to just use pre-trained model, but the problem is if you have a specific custom task, then definitely you have it gonna take a time. You have to pre-train, you have to train them, you have to fine tune them, and that's what we are going to do in this video. Okay, so this was all about introduction. So for our emotion detection, so this is our custom task. So for that we have to train them to predict if it's anger, sadness, or whatever. Okay, so for that what I have done here, I have imported import warnings. I have filtered every warning because I don't want any kind of warnings. And then what I will done here, I will have a code config completer. So if your auto completion in your cloud notebook doesn't work, like if you hit tab it doesn't complete, so what you have to do, you have to just fire up this command. It will solve every problem for suggestion and auto completion. And in this video we will first look at how to use tokenizer, how to convert our data into BERT model, because we can't directly we can directly pass our data, our text data into BERT, but accept a very specific format. So we will convert them in that specific format, and then we will see how to download pre-trained BERT architecture, how to use pre-trained BERT architecture, and then at last we will fine tune them for our custom data, for custom task, and at last we will do model evaluation. So let's get started. So right now I'm using emotion dataset for NLP. So this is our dataset. The dataset is not that big, just 20,000 rows and just 2 MB. And you can see here we have fear, we have sadness, love, joy, and so many emotions. But I guess there are 6 emotions. There are 6 emotions. So we are going to just classify them, right? So let's get started. So what I have done here, I have imported our dataset. You can see here test, train, and validation. We have 3 dataset. So okay, that's fine. Okay, so what I am doing here, since these are our text data, txt data, so for that I have just read out all those txt data set. You can see and in these data we have one input column and second one is sentiment column. So input column is the column containing all the text, and sentiment is all our sentiment like anger, emotion, and all these, and this is all separator, and I think this is pretty clear to you. Okay, so what I have done here, I have just concatenated that df full equal to pd concatenate, because I want, because these 3 dataset have the same number of columns, so that's why I'm concatenating that. And just for you can't even concatenate them, but if you concatenate them for text, because we are going to do some text pre-processing and all these, and that's why I thought it would be better if we concatenate them and then we do text pre-processing. Okay, so we have concatenating them, and you can see we have 20,000 rows, and you can see that in input column we have our all the text data, and in sentiment we have all the sentiments. So now we are going to do text pre-processing. So at this step, we are going to do text pre-processing. So for that text pre-processing, I'm going to use a text hammer, but this library created by me, and I own this library, and I will show you how to use this library. This is pretty easy to use, and this is a solution for text cleaning in natural language processing. But if you don't want to use this, you can definitely go with your regular expression. You can use them, you can build some function to clean them, but right now I will stick with this, right? So you can install with this pip install text hammer, and then I'm just imported text hammer as th, and I have created a very small function to do that. This is really very easy. So what I have done here, I have imported from tqdm.tqdm notebook, import notebook, and tqdm notebook.pandas, because I want a nice looking progress bar which will show us that the amount of data has been cleaned up. And I'm creating a text pre-processing function which will accept a data frame and then column, and this column name would be the column consist of our text data. And then I'm creating just column. This is really very easy. Df column equal to progress apply. So why are we using progress apply? Because we are using a progress bar. But if you don't want to use progress bar, you can just simply remove this progress and call the apply method. And here I'm using lambda function, and then I'm lowering case, and then on this line I'm removing context press. Like if you are is like contracted, it will remove contraction. And then removing email, removing HTML tags, you can remove stop words, you can remove special characters, you can remove accented characters. So as you can notice that I'm not removing any stop words, because okay, so the BERT model is pre-trained, and even if they are not very okay, so they are prone to not they are okay, doesn't matter you remove stop words or not. Just I want to say that it's not a very simple thing where if is all can motivate demotivate our answer. Is if all will get biased. So that's why I'm not removing stop words, because bird is doesn't gonna affect by these things, right? So that's why I'm not removing. But don't remove, because the words have some sentiment, is, was, and these have some different meaning, and that's why I'm not removing stop words. Because I was there, I am there, and all these will be removed, then the sentence will lose their intense, like okay, that's why I'm not removing stop words. Okay, then I am fired the text pre-processing, that here I have passed our data frame, and then our the column containing our text data, right? And then I have just df clean. So you can see this is kind of cleaned data, cleaned text data. And I'm creating a copy because this takes a long time, and that's why I don't want to repeat this step if something goes wrong, and I want to create a copy so that I don't so that the original copy of this df cleaned won't get changed by further processing. If something goes wrong, I will definitely copy from here. If I change this df cleaned, if I append something in this df cleaned won't get changed. Okay, so I'm creating a new column name as numwords, where I will count every words. And that's why I have used input apply lambda, and I'm counting x dot split, which will return the number of words in that sentence, in that text. And then if you just run this, okay, let's create a copy. And then I have created a df cleaned numwords, and you can see here we have number of words, count 1 2 3 4, and here 4. Okay, so but the problem is in this data that we have sentiment, and sentiment are the string, but to pass in our model it need not to be string, it must be in numbers. And that's why I have done something, right? So if I do df cleaned dot, okay, df cleaned dot info, you will see that the sentiment column is object, d type object. So what I want to convert this into categorical. So what I have done here, df sentiment equal to df clean sentiment as type category, right? So now if I run this, you will see that this is categorical column. So I will tell you what is the benefit to convert this into categorical column. Anyways, if you want to convert this in numbers, you can definitely map with a dictionary where you can give uh, where you can map sadness with 0, anger with 1, and blah blah. You can do that. And one more important thing I will show you. Just wait. Df cleaned dot sentiment dot unique. Just run this, and let me call this. So you will see that we have 6 objects: sadness, anger, love, surprise, fear, and joy. Okay, so we have changed into category. If I just df.clean that sentiment, if we run this, so you will see that we have category 6 objects, and anger, fear, joy, love, sadness. So you will see this is a list, right? And if I just run this code, sentiment.cat.codes, so all these string values will get converted into some codes. So let me run this. Okay, so these are codes. So let me tell you that what these codes shows. So 0, at 0 it's sadness, and here you can see the sadness comes at fourth index, so it's 4. So okay, third one is anger. So here anger is 0, means anger is at the first place. So this has been converted into their index of the sentiment. So this is as clear as that. And I have converted these into a dictionary, so that after getting prediction, so I can convert them into sentiment. That's why I have also created a dictionary, and this is really very easy. Anger will get 0, sadness will get 4, fear will get 1, joy will get 2, love will get 3, surprise will get 5. Okay, so just I have done that. I have converted into codes, and now if I run this, I will see that sentiment has been converted into numbers and numbers as well. And just run this command to get the maximum words. So 66 is the maximum number of words in a sentence, in a text. So we will use this later on. Just keep in mind that the number of maximum words in a text is 66. Now what I am doing, I am calling the train test split, because I want to preserve some part of data for testing and for training. So I'm just running this, and then you can see that we have trained data as 14,000 and test data as 6,000. Now the problem is the sentiment is in the number, but we want them to in categorical data. So for the categorical data means you say that we convert in one hot encoding and all this. So for that converting into categorical, I'm using Keras dot utils import categorical. And then you will see, if I call to categorical on the data train, so data train dot sentiment, you will see something like this. Okay, so what data train is, data train dot head. So this is our data train. So I'm calling to categorical into data train dot sentiment. So you can see that this will get the output. If this is 2, and you will see that 2 at the second index, I will get 1. So this will convert into 1010 and all. Okay, so now it's time to load our model, because so far we have encoded our output. So we have cleaned our input, and we have encoded our output, and we have found the maximum number of words in our text data, in our training data. So this is what we have done so far. Okay, now what I have to do, the second part, this is the second part, the text cleaning and pre-processing have done. So now it's second part. So what we have to do, we have to install the pip install transformer if you don't have transformer in your uh, environment, you have to install that pip install transformer. So I will do that. Okay, install. So I will install transformer. So okay, it has already installed, that's why requirement already satisfied. So now what I want to use, if you want to use BERT base cased or uncased, so you have to call this function. And since I'm using from transformer, I am importing auto tokenizer and tf BERT model. So what auto tokenizer will do, auto tokenizer will encode our text data into BERT input form, BERT input format. And this is tf BERT model is TensorFlow, because if we are using TensorFlow then it must be appended with tf. And I'm calling BERT model because I want to use BERT model. And then tokenizer equal to auto tokenizer dot from pre-trained, because BERT base cased comes pre-trained, and that's why I'm saying pre-trained, and the tf BERT model from pre-trained BERT base cased. So I'm calling that. Okay, and this is also the same important. If you are using the tokenizer from the same date, the same model, you have to use the model of the same type. So suppose if you are using auto tokenizer from pre-trained and you are calling distill BERT, and you are using on BERT model, tf BERT model, BERT base cased. So these model, the tokenizer and the tf BERT must be of the same type, and that's what I'm saying. So you can see that our model has been downloaded. It comes like 527 MB. Okay, so ignore this, whatever it's written, just ignore it. You can read it in free time. So we have used tokenizer and BERT. Suppose if we want to use these models locally, like okay, I want to create a Flask application where I will use this tokenizer and this BERT model. So how would we do that? So you have to call this function tokenizer.save pretrained and give whatever name you want. So if it's a tokenizer, so I will say that BERT tokenizer, and this is model, so I will say BERT model. Okay, why I'm saving these, because I want to make a Flask application for sentiment emotion detection, and that's why I'm saving. That's why I'm saving, because I want to use locally, so that's why you can save it. Okay, it's saved. Now look at this, we have some output. But the problem is how to download. You can't download it. Like okay, you can download, but you have to download the files individually. But how can download them? So to download a folder in Kaggle, what you have to do, you have to archive them. For archiving you have to import sutil.make archive, and here you have to give a file name and byte tokenizer, and you want to archive in zip, and then byte tokenizer. So run this command, and run this command as well for model. And you will see that these files have now been zipped, and you can download them, because these files are now f file, these folders are now f file. uh, let's wait until that finish. Okay, now it has completed. Now let's see that where is our file. So you can see that these are now showing download option. You can download these models, and then you can unzip, and then you can load in the same way from transformer auto tokenizer tf model, and then auto tokenizer from pre-trained, and you have to give the same file name here. And if not file name, then you have to give the path of those file, and here the same thing you have to do. Okay, and this will load you your tokenizer and BERT model. So we have loaded our tokenizer and BERT model. Now how to use them, right? Okay, the same thing if you want to load a transformer, if you want to load distilbert model, then you can use tf distilbert model from pre-trained, and then give the model name here. But I'm not going to use distilbert, so that's why I'm commenting it out. Okay, so since here we have imported our tokenizer, so let's see how to use them. If I say tokenizer and give a text here, and you will see that this returns me input IDs, token type IDs, and input and attention mask. Okay, so in BERT train, for BERT training, you gonna need input IDs, you're gonna need attention mask for sure, and token type IDs. Since you can see that this is the same values, and token type IDs are not necessary, so you can skip them, right? And you can see this 101 and 102. 101 means a star token, and 102 means int token, and these are the same as hello, and this me, and all these numbers are kind of unique, and 101 and 102 shows that now it's gonna start and now it's gonna stop. Okay, so what I'm going to use here, tokenizer, I'm going to use tokenizer. So first thing, I want my extend in this format, the format where I would have input IDs and attention mask. Okay, so I'm passing text equal to data train input. Input would be text, and I'm converting into a list. So add special tokens equal to true, and maximum length, because we saw that the maximum word length was 66, but for security I'm giving 70. Truncation equal to true. If any word have the word maximum 270, like 100 words in a sentence, and we have given the max length as 70, so truncation means that sentence of 100 length will get 70, so this means truncation. And padding means if a sentence have 35, so say 35 words, and we have given maximum length equal to 70, so it will pad up until it gets length of 70. And return tensors equal to tf, so it will say, it will tf means tensorflow, so the tensor would be in tensorflow, the tensor, this tokenizer will return would be tensor of tensorflow type. But if you want to use pytorch, you can definitely specify that you want tensor into pytorch form, so that would be pt, but now it's tf means tensorflow. And here return token type IDs. So this is our token type IDs, but I don't want, so I set it as false. And here return attention mask, I want attention mask, and that's why I said true. So input IDs are really important. Token ID type is optional, attention mask is optional, but I would say you always use attention mask because it improves you the performance, and that's why you have to use attention mask. And you can skip token ID. And here verbose equal to true, the same thing I'm saying for test. So this is our xtrain and xtest, so let's run. Okay, now it's time to see what we have xtrain and xtest. uh, x train. Okay, you see that we have in training data we had 14,000, and we had the maximum length of 70. So you can see we have input ID right here, and we have our attention mask like here. If we want to access our input ID, so how would we access? We have to just specify your column name, and that is our input IDs. This is actually a dictionary. Xtrain is dictionary, xtest is dictionary, so you can use as how you use dictionary. So now let's use our pre-trained model, and let's create an architecture according to our need. So I'm importing some libraries like ADAM, early stopping, truncate normal, and all these categorical cross entropy, categorical accuracy, and two categorical. Right? Since we have used two categorical imported already, so we really don't need. But let's run it. And then you must have to convert with GPU, as I told you previously. You must have to convert with GPU. So I'm just running this command to lift our physical devices with GPU. So we have device type equal to GPU, so it will show you that we are already connected with GPU. It's just for confirmation. Okay, so now we are going to make an architecture according to our need. Okay, let's start. So we have defined here maximum length equal to 70, and I have imported TensorFlow, and I have imported layers input dense. So we are creating input IDs because we are gonna pass input ID and input mask. So we have here input ID is equal to input layer, and then we are giving the shape, and shape would be maximum length equal to 70, because input ID, suppose one input ID would have length of 70, means it would be a list, and that list would have 70 words, and that's why max length here. And I'm saying df type, and this would be integer of 32, and I'm giving a name as input IDs. And this is again optional name, you really don't need to give it, but it's a good practice to give a name always. And here input mask, the same thing here, and this is attention mask. So here I'm using, since we have loaded our BERT model, so BERT model will contain our input IDs and attention mask, and attention mask would be input mask. And this will return us two things, and the first thing would be hidden state, and the second would be pooler output. So what we want our hidden state, because we don't want this BERT model to predict something. We don't want this BERT model to predict something, just we are using this BERT model to get hidden state, so that we can apply more layers and we get our custom output. And if I use one, so this will return our masked words and all that. So that's why we are not going to use pooler output. We are just going to use our hidden state, whatever this model will return. And attention mask equal to input mask, you can definitely remove this, but I'm not going to do that. I love to give the name of that variable. And then what I'm doing, I'm this will return us hidden states, and then I'm applying global max pooling 1D, and then I'm applying dense model dense layer with 128 neurons, then activation 128 units, and then 128 neurons, then activation equal to ReLU, and then I'm applying that. This is our functional API, and output equal to Keras layer, and then I'm adding dropout, and then again 32 ReLU, and y equal to dense, and I'm giving 6 because we have 6 sentiments, 6 emotions, and that's why I'm calling at 6. And here must be our activation equal to sigmoid, because we want our values in between 0 and 1, and that's why we are applying sigmoid. And then I'm creating a model equal to tf keras model input would be our input IDs and input mask, because in this model we are going to provide input IDs and input mask, and then output would be our y, which would be a dense of 6 neuron, right? So, and I want this model to train again, and that's why model dot layers 2 dot trainable equal to true. Why I said that? Because I want this model to train again. Okay, just run this, and model dot layers. So if you are confused why I have given 2, then you can see that 0 is our input layer, 1 is our input layer, and the second is our TF BERT model. So this is our index of BERT model, which is this one. And you can just plot them, even you can plot them. So how you can plot them? Model dot summary, or you can use uh, t, tf dot utils dot plot plot model, I guess it must be. uh, oh sorry, tf dot keras dot utils dot plot model, and then model, and then so shapes, I guess, equal to true. So you can see this, this is our input IDs and this is our attention mask, and then we are passing both into our BERT model, and then we have global max pooling and dense, and then we are going to get output of 6, uh, and we have inputted all these. So okay, now we have to compile them. For compilation I am creating a learning rate, and that is 5 e की power 5, because this learning rate is really very small, and this learning rate I have got from the Hugging Face libraries, and there were mentioned that use this library, use this learning rate to train this, and that's why I'm using this learning rate. And epsilon I have dk 0.01 and then clip norm. So I just, this is our item, because training BERT model is quite sophisticated, so you have to use a flexible learning rate. And then here we have loss. You can also freeze this BERT model, but this will not give you that much accuracy, and it will take many epochs. And what I have done here, I have not freeze it. I want this to be trained again, and that's why I have given here trainable equal to true. But you can also freeze this BERT model, but let me tell you that this will not give you much accuracy, and that will take many epochs, like 100, 200, and like that. And that's why I would prefer you to train them for your custom classification or custom task. And then I have defined a loss function, that is categorical cross entropy from large it's equal to true, and then we have matrix, and there I have given a balanced accuracy, because I want a balanced accuracy, not biased accuracy. And then I have compiled it. So run this function for eager run, and then okay, this is really very important. X would be our dictionary, right? Because in our X we will have input IDs and we will have attention mask. So input IDs would be extrain and input IDs, and attention one would be extrain attention mask. And Y would be two categorical data train sentiment and validation data. I have also passed a validation data to see our output accuracy. So for that, input IDs would be X test input ID and attention mask. And since this would be a tuple, and that's why this would be two categorical also, and we have just given a one epoch and batch size of 36. Let's run this and let's talk about more about this. Okay, let it run. Okay, so we have run this eagerly. Okay, how would we manage if we would have a very big data? So if you have a very big data, in that case I would suggest you to use a TensorFlow dataset, and then batch them, like, because if you will have a big data, you will gonna get a RAM problem, since our data has just 20,000 rows, and that's why it didn't took much RAM. But if you will have a big data, then definitely you must have to use TF dataset, and you can batch them. And okay, let's wait until it finishes, and it's gonna take a time up to 2 minutes to 5 minutes. So you have to wait for this, and you can see that our balance accuracy is really improving very fast per epoch, uh, per day, per values, right? So okay. So if you want to save this model, so you can model dot save weights and sentiment weights. So we can't save this pre-trained model saying that model dot save and give some h5, so it won't work, right? So you have to first, you have to save our model, pre-trained model, and then you have to save their weights. Okay, you can't save the whole model with weights in this BERT because it's not possible. This is possible for our other Sklearn models and other computer vision model, but for BERT you can't save, you can't say that model dot save and sentiment model dot s5, you can't say that. Like, okay, you can't do this. Let me show you what you can't do. Model dot save model dot h5. So you can't do this, you can't do this. So what you can do, so you have to first save your pre-trained model. So I have showed you how to do that. So here we go. Let me show you. So you have to first save your pre-trained model, and after saving what you have to do, you have to call this uh, model dot load uh, model dot load weights, and then you have to say that sentiment uh, weights dot h5. So you have to say, this, you have to first save your model and then you have to load weights. So on this way you can save your pre-trained model. On this way you can save your trained model, and you can deploy wherever you want. And okay, let's wait until it finishes. So guys, it has done, and you can see that we have validation balanced accuracy is 92.57, 92%, almost 93%. We have got accuracy. So if you want to save the weights, you can call model.save weights in case. So now let's do some prediction. So predict raw equal to model dot predict. So again you have to pass input IDs and attention mask. So since x test is a dictionary, so I would call input IDs and attention mask equal to attention mask. So and the whatever we input would be again in a dictionary. So so we will gonna predict it. So wait. It's using GPU for prediction. As you can see, just one epoch and we got a 93%. I would definitely recommend you to run this for 5 to 6 epochs to get 95 to 96% accuracy. Okay, it has done. Now if we run this command, you can see that we will get 1 2 3 4 5 6 6 point, because we have given dense equal to 6, and this 6 will represent our 6 emotion. So using np.argmax to get the index and get the value of index which will have the maximum value, and data.sentiment. And so this is our y true. Let me just okay, this is our y predicted, and this will be our y true. So I have imported from Sklearn metrics import classification report, and classification report data test, because in data test we also have a sentiment column, and that is called true true value. Okay, and this is y predicted as predicted value, and let's run this. And you can see that we are getting almost a very balanced value. Recall and f1 score, f1 score is always like almost 90 plus, and recall is also very good. Recall and precision is also 92% and 90%, 97%. So you can see this is a very better model. This is got the model. Just suppose this model have just ran on one epoch, and you have to run this for 10 to 5 to 10 epochs. So you can see this is our classification report. So what would happen, suppose if we want to deploy this on Flask or Django, whatever, wherever, and I want to I want to classify my own sentence, so like my custom sentence. So how would I do that? So what I need to do, text equal to input, and if I run this, this will ask me to input a text. And what I would do, I would again tokenize them. I would again tokenize that. So for tokenizer text at special token, and we have to keep the maximum length as 70 the same, truncation same, padding will do max length, return type TensorFlow, and all these. And token type ID, we don't want token type ID. And attention mask, we definitely need attention mask. Okay. And then what I will do, I will call model.predict, and I will pass these values. And since I'm multiplying with 100 because I want something big value, I want them into percent, because whatever it will predict will be in decimal, so I will multiply with 100 to get a bigger value. And let's run this. Let me input a text. I was amazed with this new song, right? Okay, let's input. Okay, it has returned 0.55, 29.62, and 35. And you can see the maximum value comes at the last, and which has fifth index. And since we have encoded a dictionary, now let's use that dictionary. Oh, encoded dict, it's not defined. Let me check it. um, it here. Okay. Now just encoded dict, and since I'm using this validation here, since validation is double double list, so I would use the first one to get values, and then I have encoded, and you can see that this is showing up the surprise maximum. Like the value of surprise is maximum, it means this sentence is a surprise emotion. Okay, let's run another one. uh, my shirt is uh, so dirty. My shirt is so dirty. And now let's run this. You will see sadness is 98%. 98% sadness, or the value of sadness is maximum 98. So you can compare that. The sentence is all about sadness. So this is all about this video, and the next video I will implement this whole model into a Flask web application. So in the next video I will show you how to implement this whole pre-trained model on a Flask application, and we will design a website where you can do sentiment analysis, you can do emotion detection. If you will input a text, and it will return you the sentiment or emotion. So this is all about this video, and thanks for watching this video. If you have any question, please leave them into comment box, and I will definitely reply them. Thanks for watching this video once again. Have a nice day, and thanks for watching this video. Please don't forget to share and subscribe if you really want to learn more about machine learning, artificial intelligence, and new technologies. Thank you very much. Have a great day.